This is the world's coal consumption chart, and this is the world's coal production chart. China almost bends both of them out of shape. By itself, China accounts for more than half of global coal consumption. At the same time, it also produces more than half of the world's coal supply. So, in an era defined by AI, semiconductors, electric vehicles, and renewable energy, why is Asia's most advanced industrial economy still consuming coal on such an enormous scale? And perhaps more importantly, is coal really as outdated as many people assume? Is coal really an outdated technology? Coal is often seen as a symbol of an older industrial era. Smoke, pollution, CO2 emissions, climate change, and from an environmental perspective, that perception is not entirely wrong. Compared with natural gas or renewable energy, coal produces significantly higher CO2 emissions per unit of electricity generated. Beyond carbon emissions, coal-fired power plants are also associated with particulate pollution, sulfur dioxide emissions, and poor air quality across many major industrial regions. Researchers at Harvard University have also published studies suggesting that PM 2.5 pollution linked to coal combustion may carry a substantially higher mortality risk compared with fine particulate pollution from several other major sources. That is one of the main reasons many developed economies have spent decades trying to reduce their dependence on coal. But there is a problem. If coal is truly obsolete, then why have the world's largest industrial economies not fully abandoned it? Even countries such as the United States, Japan, and several European economies, despite significantly reducing coal-fired electricity generation, still continue to use coal in certain strategic sectors, because coal is not simply a fuel for generating electricity. Behind it are industries such as steel, cement, metallurgy, chemicals, energy security, and many other forms of heavy industrial production. In other words, coal does not only generate electricity. It was one of the foundations of the Industrial Revolution, and even today, it still remains deeply connected to the structure of modern industrial civilization. Enormous industrial scale. One of the biggest misconceptions about coal is the idea that it survives simply because some countries are behind in technology. But in China's case, the scale of coal consumption is closely tied to the scale of its industrial system. Today, China is the world's largest producer of steel, cement, aluminum, solar panels, batteries, and electric vehicles. It is also home to some of the largest manufacturing hubs, logistics networks, and industrial cities ever built. All of that requires enormous amounts of energy, and not just occasional energy, but continuous, industrial-scale power operating 24 hours a day. Heavy industries such as steelmaking, cement production, metal refining, and chemical manufacturing consume far more energy than service-based or digital economies. Many of these sectors also require extremely high and stable temperatures that cannot easily tolerate interruptions in power supply. But electricity is only part of the story. In several industrial processes, coal is not used merely as a fuel source, it is also used as a raw industrial input. Steel is one of the clearest examples. In traditional blast furnace steelmaking, coking coal is transformed into coke, which serves two functions at the same time. It generates the intense heat required for smelting, and it also acts as a chemical reducing agent to separate iron from oxygen in iron ore. That means coal is not simply powering the process from the outside. In many cases, it is directly involved in the chemistry of industrial production itself. Alternative technologies do exist. Electric arc furnaces, hydrogen-based steelmaking, and renewable-powered industrial systems are all being developed rapidly. However, scaling those technologies to support hundreds of millions or even billions of tons of industrial output remains extremely difficult, expensive, and infrastructure-intensive. This is one of the reasons why coal remains deeply embedded in many industrial economies, despite the global push toward cleaner energy. In other words, coal is not only connected to electricity generation, it is still connected to the physical foundations of modern industrial civilization. The grid's massive backup battery. Another reason coal remains central to China's economy is the role it plays inside the national power grid. Despite the rapid expansion of renewable energy, coal still acts as a massive backup battery for the industrial system. China has become the world leader in solar and wind deployment. The country installs renewable capacity at a scale unmatched by any other economy. But large-scale industrial economies do not only need electricity, they need electricity that is stable, predictable, and available at all times. Factories, steel mills, transportation networks, semiconductor facilities, and data centers cannot simply pause operations because wind speeds fall or solar output declines at night. This is one of the core challenges of modern energy systems. Renewable energy can generate enormous amounts of electricity, but its output fluctuates depending on weather conditions and time of day. Large-scale energy storage technologies are improving rapidly, but storing enough electricity to stabilize an entire industrial economy remains technically and economically difficult. Coal power plants, by contrast, are comparatively stable and dispatchable. They can operate continuously for long periods and can be scaled to support heavy industrial demand. As a result, coal continues to function as a form of strategic grid stability for China's economy. In 2025, coal-fired power still generated roughly 50 to 60% of China's electricity supply, despite the country's massive investments in renewable energy. That statistic highlights an important reality. China's renewable expansion has been enormous, but so has the growth in electricity demand. Electric vehicles, industrial automation, high-speed rail systems, cloud computing, AI infrastructure, and large-scale manufacturing all require vast amounts of reliable power. In many ways, China is attempting to build two energy systems at the same time. One for the future, centered around renewables, and another that keeps the current industrial economy running without interruption. For now, coal remains deeply tied to that second system. Turning coal into industrial chemistry. China's dependence on coal is not only about electricity generation or heavy industry, it is also connected to a broader strategic problem: energy security. Unlike the United States or some major oil-producing nations, China imports a large share of the oil and natural gas it consumes. That creates a long-term vulnerability. A significant portion of China's energy imports must travel through major maritime trade routes, including choke points, such as the Strait of Malacca, Hormuz, routes heavily influenced by global naval power and geopolitical stability. As a result, Chinese policymakers have spent years searching for ways to reduce dependence on imported hydrocarbons. One of the most important answers has been coal, because while China lacks abundant oil and gas reserves, it possesses some of the world's largest coal reserves. That resource has allowed China to develop an enormous coal-to-chemicals industry. Instead of relying entirely on petroleum feedstocks, coal can be converted into industrial chemicals such as methanol, ammonia, synthetic fuels, plastics, and other chemical materials used across manufacturing and agriculture. Fertilizer production is one of the clearest examples. Today, roughly 70 to 80% of China's urea production is estimated to come from coal-based processes rather than natural gas. That gives China a significant degree of control over fertilizer supply and agricultural input costs, even during periods of volatility in global energy markets. Coal is also used across broader industrial chemistry sectors to support the production of synthetic fibers, industrial materials, and chemical feedstocks that would otherwise depend more heavily on imported oil. From a purely environmental perspective, many of these processes remain carbon-intensive, but from a strategic perspective, they reduce dependence on foreign energy supplies and increase domestic industrial resilience. In other words, for China, coal is not simply a fuel, it is also a geopolitical hedge. Comparing China with the United States, Japan, and Europe, China's energy strategy also becomes easier to understand when compared with other major economies. In 2024, China alone accounted for roughly 56% of global coal consumption, more than the rest of the world's major developed economies combined. By comparison, the United States represented only around 4.5% of global coal consumption, while the European Union accounted for roughly 5%, and Japan around 2 to 3%. Those numbers reflect a major shift in the geography of industrial energy use over the past several decades. In the United States, one of the biggest drivers behind coal's decline was the shale gas revolution. The rapid expansion of domestic natural gas production made gas-fired electricity cheaper and cleaner than coal across large parts of the country. Environmental regulations, renewable energy growth, and the gradual decline of certain heavy industries also accelerated coal's reduction in the power sector. As a result, U.S. coal consumption has fallen dramatically compared to its peak decades ago, dropping to roughly 400 million tons annually in recent years. Europe followed a somewhat different path. Countries such as the United Kingdom sharply reduced coal use through a combination of renewable energy expansion, natural gas, nuclear power, and aggressive climate policies. At the same time, Europe's industrial structure also evolved. Many energy-intensive industries gradually shifted toward Asia, particularly China and Southeast Asia, where manufacturing costs and energy prices were often lower. That shift is important because it highlights a broader global pattern. In many cases, industrial emissions did not disappear entirely. They were partially relocated geographically. Even within Europe, coal consumption has become increasingly concentrated in a smaller number of countries, particularly Germany and Poland. Japan presents another interesting case. Despite being one of the world's most technologically advanced economies, Japan still consumes roughly 180 million tons of coal per year and maintains coal as part of its energy mix. One major reason was the Fukushima nuclear disaster in 2011, which led to a sharp reduction in nuclear power generation for years afterward. At the same time, Japan remains heavily dependent on imported energy and requires an extremely stable electrical grid to support advanced manufacturing industries such as semiconductors, automotive production, robotics, and precision engineering. The broader pattern is not that coal has disappeared. Instead, coal consumption has increasingly shifted toward regions that continue to concentrate large-scale industrial production. And today, no country represents that shift more clearly than China. The benefits and the cost. Coal has provided China with several major strategic advantages over the past few decades. The first is scale. Access to large amounts of relatively cheap and stable energy helps support the rapid expansion of Chinese manufacturing, infrastructure, transportation, and heavy industry. Steel production, cement manufacturing, chemical processing, industrial refining, and export-oriented factories all require enormous amounts of continuous energy. Coal helped make that scale economically possible. It also contributed to China's competitiveness as a global manufacturing center. Lower industrial energy costs helped support the growth of supply chains across sectors ranging from construction materials to electronics, batteries, solar panels, and electric vehicles. But the benefits are not only economic. Coal has also played an important role in China's broader energy security strategy. Unlike oil and natural gas, which often depend heavily on international supply chains and maritime trade routes, coal is one of the few major energy resources China possesses in very large domestic quantities. That reduces exposure to certain forms of geopolitical risk and provides a degree of strategic resilience during periods of global instability or energy market disruption. Coal-fired power plants also continue to provide large-scale grid stability for an economy that increasingly depends on uninterrupted electricity. In many ways, coal has acted as a foundation for China's industrial rise. But those advantages have come with major costs. Coal remains one of the most carbon-intensive energy sources in the world and is closely associated with air pollution, particulate emissions, and large-scale CO2 output. Today, China is also the world's largest emitter of carbon dioxide in absolute terms, largely because of the enormous scale of its industrial economy and energy consumption. That creates growing international pressure surrounding climate commitments, emissions reductions, and long-term decarbonization targets. It also creates a difficult economic challenge. The larger an industrial system becomes, the harder it is to rapidly replace the energy infrastructure supporting it. China is therefore attempting to manage two transitions at the same time, continuing economic and industrial growth while gradually reducing dependence on carbon-intensive energy. That balancing act may become one of the defining economic and geopolitical challenges of the coming decades. China's energy paradox. Perhaps the biggest paradox in China's energy story is that the country leading the world in renewable energy expansion is also the country consuming the most coal. China installs more solar and wind capacity each year than any other nation. It dominates global supply chains for solar panels, batteries, electric vehicles, and many key clean energy technologies. In many areas of the energy transition, China is not lagging behind the world. It is helping drive the transition itself. And yet, at the same time, coal consumption continues to remain extraordinarily high. At first glance, that appears contradictory, but from an industrial and energy systems perspective, the situation is more complex. China's renewable energy growth has been massive. However, the growth in electricity demand has also been massive. The country is simultaneously expanding industrial production, urban infrastructure, high-speed transportation, digital infrastructure, electric vehicles, automation, and AI-related computing capacity. All of those sectors require enormous quantities of electricity. As a result, renewable energy in China is not simply replacing an old energy system. In many cases, it is being added on top of a rapidly expanding overall energy demand. That distinction is critical. In some advanced economies, electricity demand has remained relatively stable for years, making it easier for renewables to gradually replace fossil fuels. China faces a different challenge. Its total energy demand is still growing at an enormous scale. This is one reason coal has remained deeply embedded in the system, even while renewable deployment accelerates. In other words, the issue is not that China has ignored clean energy. The issue is that replacing the energy foundation of the world's largest industrial economy is an extraordinarily difficult process, technically, economically, and strategically, and at least for now, renewable energy alone has not yet been sufficient to fully replace the scale, stability, and industrial functions that coal continues to provide. There is also a broader global dimension to this story. Over the past few decades, many advanced economies have reduced their direct coal consumption, but at the same time, a large share of global manufacturing shifted toward China and other parts of Asia. That means many products consumed around the world, from construction materials and electronics to batteries, appliances, solar panels, and industrial goods, may still be connected indirectly to coal-intensive industrial systems. In other words, lower domestic coal consumption in some countries does not necessarily mean the industrial energy behind modern consumption has disappeared entirely. In many cases, parts of that energy demand were simply relocated geographically through global supply chains, which makes the story of coal not only a Chinese story, but also part of the broader story of how the modern global economy actually functions.